Hello, very good afternoon, everyone. Could you please confirm once that you can see me, you can hear me, as well as you can see this presentation?
Yes, sir.
Okay, thank you so much. So, very good afternoon, everyone. My name is Ambuj. I am a research scholar at Agriculture and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session for the course Computer Vision. This course is taught by Professor Jayant Mukhopadhyay from IIT Kharagpur. And what I'll be doing in this particular session that I'll be sharing some of the objective type questions based on the previous week's content in front of you all, and you will be solving those particular questions, and then we'll try to discuss what are the concepts and where what are the other topics from which questions can be asked. Okay, just a second. Yeah, just 1 second. Yes. So before the start of the session, I'd like to request you all please take a notebook and pen with you all, okay, so that you can jot down some of the questions, some of the basic points, some of the arguments, as well as some of the concepts which I'll be sharing. Okay, it would be very much helpful for you in the future classes as well as in the examination also. Please take a note of what I am sharing with you. And regarding the PDF, okay, let me just share the link. Just 1 second, I'll share the link. Okay. This is the link for the all the PDFs as well as the recorded sessions. What have been I have been taking since the start of this course, as well as for all the three sessions. You will find the YouTube recordings, okay, lecture recordings, as well as the PDF of the particular session. Okay, so let me just begin. The question number one for the present session is this one. Given the right epipole E dash or E prime equal to 2 comma 3, point X dash equal to 5 comma 2 in the right image plane of a stereo setup, compute the epipolar line L dash containing X dash expressed in homogeneous coordinates and normalized so that the last component is plus 1. In all of the options also, one option you can directly eliminate, that is this one. Okay. because it is having -1. Okay, last component should be +1, and note down the right epipole as well as the point x dash. Okay, try to note it down. Then we'll discuss how to solve, how to tackle this particular type of question. Okay, try to note down the question. The stereo setup geometry has been already taught in the previous week. Okay, we will recall some of the concepts. I'll try to explain how things are happening here. At the end of the session, I'll show you a lot of applications. For example, in the previous session, I showed some of the applications of calculation of the different points, okay, depth as well as the crop row detection. In my own research, I have shown. In today's session, I'll be sharing some of the research papers also, okay, in which you will find a lot of applications of the stereo geometry. Okay, so please bear with me. This is a very interesting topic. Stereo geometry. If I tell you the most relevant example is our eyes. Okay, our eyes are placed at a distance of 1.6 centimeters or so from one another. Okay, so both of the eyes are capturing different views. Okay, one eye is capturing another view of the same thing, and another eye is capturing another view of the same thing. And the brain combines both of the views simultaneously so that you are able to see things in three dimensions. Otherwise, you would be able to only see the things in one dimension. Okay, so this is a practical example of stereogeometry. By stereogeometry only, we are able to only not only see things in three dimensions, but we are also able to perceive a sense of depth. Okay, so it is just like a 3D animation view. Okay, in three dimensions, you are able to touch things, you are able to feel things, you are able to judge the depth only because of the stereo vision which our eyes are having. Okay, if you would like to know about what are the applications, other applications of neuromorphic computing means the computation which involves human body, human mind, as well as the human vision system (HVS). Then please bear with me. At the end, I'll show you that. Okay, in my own research, I'll show you the principal applications of stereo geometry. If you would like to know, they are mainly confined towards autonomous driving. Okay, autonomous driving is heavily involved, as well as in some of the space applications you will find, in which pinpoint judgment of the distances have to be made. Like in docking and undocking of the space capsule, this particular thing was earlier used. Okay, late in late 80s and 70s. Nowadays, a lot of sensors have come into play, which tell you the distances up to third level of or even 10 level of millimeters. Okay, 10 decimal places till millimeter length. Nowadays, more advanced sensors have come. Okay, but in previous times, this technology was very much used. Immersive technology, which you are seeing, like in nowadays, if you will try to see 3D animation. Okay, 3D animation was a later on concept. Okay, was an earlier concept. Nowadays, in OLED displays come directly fitted inside the AR VR lenses. Okay, so much a lot of progress we have just seen, starting from basic stereo vision calculation of the distance towards nowadays. Okay, so please be with me. Okay, let us learn some of these mathematical concepts from question number 1 to question number 10. And at the end, I'll show you a lot of principal applications. Okay, from my own research, I'll show you one research paper. Okay, as well as I'll try to show you another research papers also. Okay, in which a lot of applications of these basic mathematical denominations are there. And if you want to know the concepts in detail, what are the different theoretical concepts, then please go through all the lectures which are released week wise. Okay, try to go through all the lectures. Please, my sincere advice to you is, if you want to pass this course with flying colors, okay, then this is the one and only way. Okay, then attend any of the three sessions. Okay, doubt solving sessions. Try to clarify all your doubts. Okay, which either have come through assignments or any other doubts are there. Okay, or you want to know what are the principal applications or anything like that, okay, then please go through the live interactive sessions. But sincere advice to use that before the examination, please clear all your doubts so that in the examination, no if and but is there. Okay, I'm not directly able to assess your all performances in the assignments. I don't know about anything about it, but still I am hoping that you are all are solving assignments. Okay, watching all the lectures, and after the end of the week, these live interactive sessions, three particular sessions are there. So take maximum benefit from these three sessions, okay, and try to clarify all your doubts. And at any point, if you are having any doubt, feel free to ask, okay. And always take a pen and paper. At least try to note down what is the question. And after the session is over, howsoever I have solved, please try to solve it step by step, okay, because if you will not practice, then there is no chance in the examination that you are able to solve these lengthy calculations. In the previous session also, question number 6 and question number 7 I solved step by step in front of you, okay. So that was taking, that at least took half an hour for me to solve, okay. So you please try to bear with me, okay, try to religiously solve all the questions, okay. In till week number 5, not much principal applications are there. After week number 5, these sessions are much practical, okay. They are much practical, as well as the principal applications are also there. You will feel much connected, okay, that I can assure you. But till the portion which I will cover till week number 5, it will be there in the examination. A lot of mathematical things are there, okay. You need practice. At least spend one day. If you are a college student, if you are not having any time, okay, at least spend one day, try to solve all the questions which I have solved in this PDF, okay. Take this PDF, it is free for you to use, okay, and then please proceed, okay. These instructions I have repeated multiple times, okay. Still it is my duty to repeat in every session. That is why I am performing my duty, okay. At any point of time, if you are having any doubt, feel free to unmute, feel free to ask. Okay, I'll explain you once again, thrice again, twice again. Okay, this is my own personal advice. Okay, so with this spirit, let us begin this particular session. Okay, the correct option would be D1. Okay, in this type of questions, directly I told you that you can eliminate one option because it is mentioned that the last component should be +1. Okay, so now you try to see how this particular thing has been given the homogeneous form. In homogeneous form, if you will try to jot down the epipolar line E dash, right epipole already given 2, 3, okay. One always you can add since the last component already has been given, it is +1. So here also you can add it. E dash you try to jot down, then X dash try to jot down. Then you try to compute the product L dash, E dash cross S dash. Okay, cross product you already know, I, J, K, write down all the components. Okay, multiply. Then after that you try to normalize. Why you are normalizing? Because you want at the end last component should be +1. Okay, you try to divide everything by -11, you will directly get option D. Okay, this is shortcut explanation. Let us go deep into the detail. In your stereo vision system, okay, in your stereo imaging system, two cameras, each 3D point, they are taking the images of 3D in three dimensions. Okay, they are projecting into 2D plane, one in each image. Okay, the epipolar geometry describes the intrinsic projective geometry between these two views, independent of the scene structure. Okay, first you have to understand what is an epipole. Epipole is the projection of one camera center onto the other camera plane. Okay, this is epipole. What is epipolar line? The line on one image where the corresponding point from one image from other image must lie. Okay, these two have to be merged. Then what is epipolar constant? If a point x in the left image corresponds to a point x dash in the right image, then the x dash lies on the epipolar line L dash induced by x. Okay. What is the goal of the problem? You have been given the right epipole, which is E dash, belongs to relation R square. Okay. A point x dash okay, belonging to relation R square in the right image, and you are asked to compute the epipolar line L dash in the same right image, passing through the given point X dash, okay, defined by the right epipole E dash. So core concept is this one, that in projective geometry, line passing through 2 points A and B is given by the cross product. Okay. Basic operation in homogeneous coordinates. So to find your epipolar line L dash, you have to compute the cross product E dash cross X dash. Okay. Here, what does it mean? Both E dash and X dash are just converted to homogeneous 3D vectors just by appending one. Okay. E dash you try to write down, X dash you write down, then you try to formulate what is resultant L dash belonging to RQ in homogeneous representation of a line. Okay, line equation is ax plus by plus c equal to 0. Okay, so geometric interpretation, the epipole E dash is the point through which all the epipolar lines in that image plane pass. L dash equal to E dash cross X dash, that is the unique line, passes through E dash, passes through X dash. Okay, in projective geometry. Why are you normalizing it? Why? Because it has to be scaled arbitrarily in homogeneous coordinates. It means that L dash and K into L dash, they will represent the same line. Okay, that is why you are making the component last component as +1. You can always look for that. Okay, coming towards the next question. In the previous question nothing was there, just append one, make the cross product, find the line passing through E dash and X dash. Okay, coming through the second question, assume that a stereo imaging setup has two image planes left and right. Which of the following could be the possible right null vector or the left epipole for the corresponding image setup? And you have been given the fundamental matrix, that is 20 12 0, 8 minus 7 59, minus 4 33, minus 77. Okay, and the options have been given. You can apply the shortcut which I told in the previous session also. Okay, if you don't find the calculation much involving or much connecting, okay, you can always apply the shortcut which I showed in the previous session. Okay, go for it. Otherwise, here I'll show you the step by step calculation. Okay, because at the end you might get confused, so it is better if if you are having time, then please do try to calculate only. Okay, it would be much more helpful for you. Okay, yeah, try to at least note down this fundamental matrix F. Okay, what are the different components in your notebook? Please jot down question number one, then what is question number one, jot down question number two, what are the different things which are given in question number two. After the session is over, take this PDF, go through everything step by step, try to solve it down with your own hand. If some calculation mistake is there, please come up with me. I have also given my mail ID. Okay, share within it that sir, you have solved this thing wrong, this will be solved like this. Okay, try to interact as much as possible. Okay, that is the thing. Yes, it would be C. Okay, I'll just show you how to solve it. You need right null vector, okay, or the left epipole. It should satisfy f into e equal to 0. F already has been given to you. E you can write it down as x y 1. Last component always you have to make as 1. Okay, so f into e equal to should be 0. Okay, means 0 means nothing but 0 0 0. Correspondingly the matrix multiplication would be there. Okay, so if you will try to go through the options, okay, already showed you in I think question number 8, not in question number 8, at the end of the question number 7 in the previous session, already showed you this, how it works. Okay, so f into e should be equal to 0, e already given to you. Okay, e already given to you. Okay, in terms of the options. Okay, just try to perform the matrix multiplication, and if you are lucky, then at the end of option number B only you would be able to achieve the success. You will get it the dot product as 0. Okay, this was regarding your option number C is also giving you 0, and option number D is also giving you 0. So C is the only candidate. Okay, no, 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 no. but it is not giving you the transformation. Direct 0 it is not giving you. Yes, 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 yes. Everything is perfectly fine. Okay, just 1 second. Yeah. Try to fix in all the options. Okay, that is the only thing. Sorry for the mistake. It would be option number C. C is giving me 0, 0, 0, not option number D, not option number B. Okay. Simple concept is there, f into e equal to 0. Okay, simple concept is there that you have to apply. Okay, e as x y z, x y 1. Okay, and f directly has been given to you. Try to plug in the options, and wherever you find that it is equal to 0 would be sufficient. Okay, now you try to see that in stereo vision setup, two cameras they observe a 3D scene from different viewpoints. Already told you. Epipolar geometry captures the projective relationship between these two views without requiring explicit knowledge of the scene structure. Okay. So two of the principal concepts are fundamental metrics and the epipoles that we will try to explore in detail. Fundamental matrix F is given as relation R 3 by 3. It encodes how points in the left image map to epipolar lines in the right image. For any corresponding homogeneous image points x and x dash, the epipolar constant is x dash transform, okay, transpose fx. Okay. So properties are, it is a rank 2 matrix, means it is 1 0 singular value. Okay. It is defined up to scale. Then your epipoles are left epipole, projection of right camera optical center into the left image. Right epipole E dash is the projection of left camera center into the right image. And your geometric rule is all epipolar lines in the left image must pass through left epipole. Already seen in question number 1. Okay. All epipolar lines in the right image must pass through the right epipole. Okay, all epipolar lines in the right image pass through right epipole, that is E prime. Okay, now you if you try to see epipoles as null vectors because f is having rank 2, so the right null space f into E should be equal to 0, where E is the left epipole in the left image. Okay, and right epipole E dash transpose f equal to 0 means E dash is the right epipole in the right image. Okay. Now, how to compute this particular epipole? Assemble f. Okay, f already given to you. Then you try to solve the homogeneous system f into e equal to 0 or f dash transpose e prime equal to 0. Then you try to normalize the solution by making the last coordinate as +1. Okay. For example, f has been given to you. Okay, then you directly you can just make it as in this equation also. If you don't want to plug in the options, okay, then also there will be system of equations. Okay, two system of equations will be there. Okay, not exactly two, three would be there. Okay, so you will be having more than one solution. Okay, try to eliminate join two equations, try to make them one, then you would be having a particular solution in form of kx, x equal to k into some value, okay, where k will be some constant. Okay, so in that particular form, because since two variables are there and three number of equations you will be getting, so you will always have the probability of more than one solution or exactly two solutions. Okay, but better approach would be just to plug in the options because in the examination time is very limited. Okay, why epipoles they matter? Because aligning epipolar lines horizontally depends on knowing E and E dash. Correspondence search to find the matching point for X in the right image. You constrain search to its epipolar line L dash equal to Fx. In case of your 3D reconstruction, triangulating a 3D point from its projection requires knowing the relative camera geometry. Already told you what is camera calibration, what are the different parameters which are involved in camera calibration, discussed in great detail in the previous session itself. Okay, so in summary, the epipoles are the kernels of the fundamental matrix. They tell you exactly where all the epipolar lines converge in each image. Finding them simply a matter of solving the homogeneous linear system, and then normalizing the result. Okay. Now you see question number 3, 4, and 5. Consider a stereo imaging setup camera with left calibration matrix k equal to this particular matrix, right calibration matrix already given to you, and right camera has R already given to you. Based on the given parameters, you have to solve how many questions? 3, 4, and 5. Okay. First of all, you have to find the homography matrix H. Okay, try to find it down. At least try to note down matrix K dash, matrix R. Then I'll show you how to calculate the homography matrix H. Okay, this is the thing. Try to note it down. Okay, what are the different parameters have been given? Try to recall the relations if you want. I can give you time for solving also. Okay, take 2 minutes time. Try to recall the relations. Okay. Yes. Now we shall proceed. Okay. Homography matrix. Okay. To derive the image to image homography, where the relative motion between two cameras is pure rotation, no translation was there. Okay. You use the well known formula H equal to K dash R K inverse. Here also you have to calculate an inverse. And if you are not habituated of calculating the inverse, then I don't think so in the examination within the stipulated time you would be able to calculate the inverse of a matrix. Still, I remember in my class 12th, a question was there regarding the solution of the inverse. I solved it correctly, but it took me at least half an hour because in inverse, lot of steps are involved. Okay, so here you try to see that while calculating the inverse, the steps are interlinked with each other. So if at any point of time you will be committing a mistake, you would be committing mistake in the entire sequence. So beforehand, you have to keep on checking that whether I have calculated all the minors, all the cofactors correctly or not. Okay, this is the thing. So k dash, you have to calculate k as a matrix has been given to you. Okay, sorry, k inverse you have to calculate. K dash as a matrix has been given to you. R has been given to you. Everything has been given to you. Okay. Now k dash would be nothing using the property k into k inverse equal to I or identity matrix. Okay, you try to compute what trick I have applied here, that if you are given a matrix, okay, you just have to ensure that inverse of that particular matrix would be that thing only, that particular matrix only, by multiplication of which it would be exactly equal to identity matrix. Okay, so if you will try to see that I divide all the elements by the largest element, okay, then it would be coming directly or exactly it as the inverse matrix. Try to compute. Okay, divide it by the largest element, and then you try to see. Okay, whether it is coming or not. Okay, divide all the elements. Okay, by the largest element. Okay, then you try to see whether this particular matrix is matching or not. Okay, sometimes adjustment also has to be made. In the previous session I showed you that one such arrangement, but it was restricted only to the matrix in which only the elements were involved, diagonal elements were involved. But here a lot more elements are involved. So you just have to write down both the matrices simultaneously and make some adjustment such that the multiplication of both the things is equal to both the matrices is equal to identity matrix. Okay. Why we are doing so? We are not going through the particular standard procedure, which is the detailed procedure. Why we are doing so? Why we are doing so? Because it will take us a lot of time. So we are trying to conserve some amount of time. That is the only the reason. Okay. So K dash K inverse we already have calculated. Okay. Now you try to calculate K dash R K inverse. Okay. First compute R into K inverse. Okay. Yes. Any doubt?
Yes, sir. By coding, we also can calculate the inverse also. In exam, it's allow us.
No, no, no. In the examination, you have to calculate the inverse by using pen and paper only.
Okay.
Okay. If this subject is such that in from the beginning of the session you are only given coding assignment, still the way the assignment you are given and the way the assignment is solved is the same pattern in the examination.
Okay. So it's
Okay.
take lot of time.
Yeah, it will take lot of time. That is why I am telling you that some of the tricks you can apply. Okay. While calculating the inverse, because some of the elements are zero here. So some
Mm.
adjustment can be made such that
Mm.
the multiplication of both the matrices is equal to identity matrix, which you already know. Okay.
Yeah.
Now you try to calculate H equal to K dash R K inverse. Okay. First of all, we'll calculate the R into K inverse, R matrix given to you. Okay. K inverse you try to just multiply it down. Okay. Then K dash will be multiplied by K dash, and then you try to match it with option number B. Okay. B would be the correct option in this particular case. Okay. In case of question number 4, you are given a translation vector t as 101. You have to compute the right epipole. Okay. Now you try to compute. Okay. Uh, Note down the translation vector t. Okay. Please jot it down. Yes. Right epipole already given as k dash t. Okay. Find the right epipole. You need to recall that the projection of left camera center at the origin of the left camera frame into the right image. Okay. Since the left center in the right frame is simply the translation of vector t in the homogeneous coordinates, okay, e dash is directly proportional to k dash t, t already given to you, okay, k dash from the question number 3, 4, and 5, okay. Directly there k dash has been given to you, okay. You have to compute k dash t, simple matrix multiplication is there, okay. So then you will get the option as 4, 2, 2, okay. Now you can just try to normalize. You will get 2 comma 1 comma 1, okay. Oh, need not to normalize, okay. Directly it is matching, I think, with option number A. Let me just check. Okay. Yeah, it is directly matching with option number A. Okay. Yes. Near stereogeometry, epipole is the one image is the image of the other camera's optical center. Okay. Equivalently, it is the point where all epipolar lines in that image intersect. Okay. So two dual epipoles are there. Left epipole E is the projection of the right camera center into the left image. Right epipole E dash is the projection of the left camera center into the right image. Now epipoles are simply the projection of one camera center into the other's image. Compute them by taking the translation, okay, plus rotation if the origin is in aligned into the target camera frame. Then you have to project via taking the intrinsic matrix, okay. Why our epipole are mattering? Because for any point x in the left image, its corresponding point x dash in the right image must lie on the same epipolar line, that is L dash equal to f into x, okay. And in your search constant, you have to find the exact match for x. You only need to search along the line L dash. In case of your rectification, in case of your camera calibration, these are very important for ensuring the parallel scan lines. Okay. For computing the right epipole from the camera motion, you have to assume that left camera in our world is at the origin, right camera is related by a rotation or translation. Okay. Left camera center is at 0, then right camera center is at t. Okay. Then you have to calibrate both of the cameras. Okay. And the expressions already have been given here. Okay. Find the fundamental matrix F. Okay, this is the last question in conjunction with question number 3, 4, and 5. Okay, so fundamental matrix F is nothing but E dash cross product H. Okay, H is K dash R K inverse calculated from question number 3. From question number 4, E dash is calculated. Now you have to compute the skew symmetric matrix. Okay, E dash X. Okay, you can denote it by any symbol. Okay, here I have denoted by the symbol X or cross. Okay, so that you try to compute. Okay, for 4 2 2, this one will be the skew symmetric matrix. Okay, then you try to just multiply. Okay, both the matrices, and directly after the matrix multiplication you will get the fundamental matrix F. Okay, which would be very much helpful for you to calibrate the camera. This is the principal application. Okay. Key relation is E dash skew symmetric matrix multiplied by H. Okay. Ties together three geometric facts in pure rotation stereo setup. Okay. Homography H under pure rotation when the two cameras differ only by rotation R. Any 3D ray through the left camera center projects to pixel X in the left image to pixel. Okay, x dash equal to hx in the right image where h equal to k dash r k inverse. H carries each left image point to its corresponding right image point under that rotation. Okay, so your epipole e dash would be somewhat like this, and try to compute the entire skew symmetric matrix using this particular relation. Okay, that we already have seen. Just okay, ex, ey, ez already has been given to you. Directly we have put on this relationship and we have found the skew symmetric matrix. Okay, then you try to compute the cross product. Okay, constructing the fundamental matrix, by definition the fundamental matrix F should must map the left image point x to the epipolar line L dash in the right image where L dash equal to F into x. In our rotated setup, okay, the corresponding pixel is hx. Okay, and the epipolar line through that pixel and the epipole is L dash equal to E dash into Hx. Okay, or skew symmetric matrix Ex into Hx that we have computed, and we have found the F. Okay, how it is working? The homography setup Hx finds the match point under pure rotation. Cross product E dash Hx draws the line through E dash and that match point. Packing them together will give you the fundamental matrix in one neat product. Okay. The expression, this particular expression, please do try to remember. If you are given the matrix E, then how to calculate this symmetric matrix. Direct an expression is there. Okay, do try to remember. Otherwise, in the examination, you can calculate also. Okay. Now, in the similar trend, there will be two conjunctive questions. It is question number 6 and question number 7. You have been given the fundamental matrix F. Okay. Based on the given data, you have to solve question number 5 and question number based on the given data, solve the following questions, not 5 and 6, 6 and 7. Okay, where their mistake is there. Question would be 6 and 7. Okay, yeah. Fundamental matrix F has been given to you, and 2 points 5 comma 8 and 7 comma minus 5. They have been given in the left image. You have to compute the epipolar lines. Okay, try to compute. The epipolar line will be given by L dash equal to Fx. Okay. First of all, matrix, fundamental matrix F has been given to me. Okay. X1 has been given to me as 5 comma 8. X2 has been given to me as 7 comma minus 5. Okay. Now we want the corresponding epipolar lines L1 dash and L2 dash in the right image. We have to compute L dash as Fx. Okay. So first point is 5 comma 8. Okay. In homogeneous coordinates, you can write it down as 5 comma 8 comma 1 transpose. Okay. L1 dash equal to F multiplied by this particular point. That L1 dash will be 21, 13, 13. Simple matrix product is there. Okay. Not much to panic. Okay. F already given to you in homogeneous coordinates. You will write down the corresponding point x1. Then you will try to do the matrix multiplication. Okay. And you will directly get it as 21, 13, 13. Okay. Second point already given to you x2. Okay. X2 as 7 comma minus 5 comma 1. Okay. So you try to compute the line compute L2. Okay. So L2 dash is been given to you minus 22 comma 2. Okay. Matching to the choices, it would be option number B. Okay. Minus 22 comma 2, 21, 13, 13. Okay. This would be the answer. Correct option would be option number B. Okay. This is regarding question number 6. Simple relation is there, not much calculation is involved. Okay, try to revisit the lecture once again after the session is over. Try to take down the PDF, note down the question, compute, use the options using various relations. Okay, try to see everything down. If you try to compute the right epipole, okay, right epipole is E dash equal to L1 cross L2. L1 dash you already have calculated in the previous question. Okay, L1 dash already calculated in my previous question. L2 dash already calculated in my previous question. Now E dash I'll try to compute, and how I will compute, I'll take the cross product. I, J, K and jot down various x and y, z, x, y, z components. And after the cross product, you will get it as 0, comma, minus 302, comma, 302. I think it would be matching with option number D. Okay, option number D would be the correct option. Okay, in your epipolar geometry, the epipole in an image is the single point through which all epipolar lines in that image plane pass. Equivalently, it is the image of other camera's optical center. One powerful and very geometric way to find the epipole is to note that the common intersection of any two distinct epipolar lines. Okay, so point X in the left image has been given to you. Okay, epipolar line L dash will be equal to F into X. Okay, F is 3 by 3 matrix. Okay, every point X dash in the right image plane must line to pass through the right epipolar line or the F transpose into X dash in the left image. Okay, then you will be having this particular equation. Okay, so epipole as a null vector should satisfy F dash, where F is the fundamental matrix, F transpose E dash equal to 0. E dash spans the left null space of F. Okay, so the epipole as intersection of epipolar lines. Geometrically, all epipolar lines L dash must pass through E dash. Hence, you need to take any two distinct epipolar lines L dash, L1 dash and L2 dash, and their intersection should be exactly E dash. Okay. So E dash equal to L1 dash cross L2 dash. Okay. I, J, K matrix given A1, B1, C1, A2, B2, C2. Directly compute the cross product. Okay. Why you are doing cross product? Because the meet or the intersection of two lines is there dual operation. Okay, and dually the join is also given as the cross product of the 2 point vectors. Okay, so line intersection as well as the point joining are both mediated by the same bilinear wedge product or the cross product in your projective coordinates. Okay, so we have just seen this particular worked in illustration also. Okay, what are the key takeaways? The fundamental matrix encodes how points map to epipolar lines. Epipole is the single point common to all those lines, and the line intersection in homogeneous coordinates is naturally given as the cross product. Okay, these three are the different key takeaways. Okay, just 1 second. Yeah. So in this particular question, consider a stereo imaging setup with two cameras P. Left camera has been given to you. Right camera has been given to you. You have to calculate F and the right epipole. Same as question number 6, 7 as well as 3, 4 and 5. Okay. So please note it down. Already shown you the relationships. Okay. I'll give you solid 5 or 7 minutes time. Please note it down. Try to solve. Okay. Try to solve. If you encounter any difficulty, then we will discuss. Everything much explained to you in great detail. Okay. Take few minutes of time that will enhance your memory skills also. Try to note all these things down. Try to compute the fundamental matrix F as well as the right epipole. And I'll just see you in just 5 minutes. Okay. Try to note it down. Already explained question already has been explained to you. These 3, 4, 5 as well as 6, 7 question. All the questions were nearly having the same relationships. Okay. Please note this particular question down. Try to revisit, try to recall the concept and try to calculate. Okay. See you in 5 minutes. Yes, very good, Maqbool Hussain. Very good. You have calculated option number C. Very good. It is indeed remarkable. Okay. And your correct option would be B and C. Okay. It was an MSQ where it has been mentioned. MSQ is multiple select question. In the examination also, try to be very, very careful whether it is option number A, B, whether it is a MCQ or it is a MSQ. MSQ is multiple select question. Okay. And Mansoori has also calculated it as correctly. C option and B, yes. C option and option number B, very good, very nice. Both of you are correct. Maqbool is partly correct and Mansoori is fully correct. Okay, this is the thing. If you will pair the camera, okay, the pair of camera P and P prime, you try to first of all segregate the matrix M, which we have done in our previous session. Similar to that, okay, then we try to segregate T, okay, right epipole E dash, okay, is the projection of the left camera center, which is 0, 0, 0, 1 transpose in the right image. E dash already given to you, T already given to you. The fundamental matrix F is nothing but E dash cross, okay, skew symmetric matrix of that multiplied by M. Skew symmetric matrix, how I have calculated, I have used the same notation, okay, that I have already shown to you in the previous question. In MSQ type, it's mentioned that it's MSQ question. Yes, 100% it would be mentioned whether it is a MSQ question or a MCQ question. It would be mentioned even in your JEE Advance, in your GATE examination, all in both the examinations as well as in any examination, it would be 100% mentioned whether it is a multiple select question, multiple choice question. Okay, that would be mentioned. So you not need not to worry about that. Okay, just 1 second. Okay. It would be mentioned in the question itself. Okay, whether it is a MCQ, whether it is a MSQ. Okay, it would be mentioned. Okay, so if you carry out the cross product, you will get it as 404 minus 2, 230 minus 4 minus 10. Okay, that will be matching option number C. And the right epipole is 1 comma 2 comma 1, which we have calculated just in the starting itself. Okay, so C would be correct, B would be correct, B and C both would be correct. How they have come, that is already mentioned here. Into a two view projective setup, fundamental matrix F and the epipole E and E dash capture all of the projective correspondences between two images without any knowledge of scene geometry. Here is all the pieces here, how all the pieces fit together. P already given to you, P dash already given to you. P is the left camera at the origin with orientation I. P dash as a 3 by 3 matrix M and translation T. Okay. Epipoles has projection of camera centers. Left camera center into the homogeneous world is C equal to 0, 0, 0, 1 transpose. Now you have to project C into the right image, which gives us the right epipole. Okay. Now dually the right camera center will also project, okay, left image as the left epipole equal to P M inverse T 1 and transpose of that for a canonical left camera image. Okay. For any corresponding pair of images x and x dash, the epipolar constant x dash t transpose fx should be equal to 0. Fx is the epipolar line L dash and dually f dash f transpose x dash is the epipolar line in the left image containing x. Okay. Constructing f from p and p dash already given to you. E dash skew symmetric matrix multiplied by m. M is the 3 by 3 left block of P dash and E prime is the 3 by 3 skew symmetric matrix of the right epipole defined so that for any vector V, your E dash V is equal to the cross product of E dash and V. Okay. So why this particular relationship holds? Because for a left image point x, corresponding projected point under P dash is x dash equal to mx. Okay. Line through right epipole, the true epipolar line in the right image is the line joining the epipole E dash and x dash prime. So L dash equal to E dash cross product of x dash. Okay. So in matrix form, fx should be equal to 0. Okay. Fx should be equal to E dash skew symmetric matrix mx. So E dash as a skew symmetric matrix multiplied by m. Okay. So E dash skew symmetric matrix you will directly able to calculate using this particular relationship. Okay. Directly use this particular relationship. Okay. And we will calculate. Then you will have a full 3 by 3 fundamental matrix. Okay. Putting it all together, subtracting t equal to e dash from p dash equal to m prime t, you have to build e dash, multiply f, then in option you can scale f also. Okay. So it is useful for your camera calibration, for your 3D reconstruction, as well as for a rectification. Okay, rectification means correction while camera calibration. Okay, that is the rectification. Just 1 second. Yeah. So given the right camera, question number 9, as r equal to this particular matrix has been given, translation vector t has been given to you. You have to compute the essential matrix E. Try to note it down. Take few minutes time. Okay. Similar to the previous question, take 5 minutes good time. Okay. Try to note it down. Recall the relationships. And if you are able to solve, then it is a wonderful thing. Okay. But if you are not able to do so, we'll just discuss. Okay. Try to note down right camera R, translation vector T. Try to compute the essential matrix E. Take good amount of time. If you are still not able to solve, then we'll discuss. Okay. Option number C, very, very good. Very good. Very nice. Sir, by schematic matrix, we could solve it. Yes, yes, yes. Definitely, you would be able to solve it with the schematic matrix. Okay. We'll just see. Just wait. It would be option number C only. We'll just see. Okay. Essential matrix E encodes the epipolar geometry between two calibrated cameras. Okay. It is defined by relative rotation R and translation T between the two particular cameras. Okay. T is a skew symmetric matrix multiplied by R. Okay. Now T is the 3 by 3 skew symmetric matrix which should be satisfying T cross V. So concretely for a translation vector T equal to Tx, Ty, Tz. Okay, transpose already given to you. Now skew symmetric matrix would be given by this particular relationship 0 minus Tz, Ty, Tz 0 minus Tx minus Ty, Tx 0. Okay, that you can just jot it down as a direct relationship. Okay, so E equal to the skew symmetric matrix T multiplied by R. 3D point X projects into the two camera images as x small x equal to px and x dash equal to p prime x. For calibrated cameras, we work in camera normalized candidate coordinates so that x equal to k inverse u and x dash equal to k dash inverse u dash. Okay, and projection matrices reduced to up to the scale I and R. Okay, then your epipolar constant in normalized coordinates is x dash transpose Ex equal to 0. So geometrically, array through x in the first camera when expressed in the second camera's frame rotated by r and translated by t. So the locus of all possible matches for x in the second image is the line through t with direction rx. Algebraically, that line is L dash equal to T and cross product Rx. Okay. Tx Rx. Okay. So E is nothing but the skew symmetric matrix T multiplied by R. R as a relation has been given to you, T already given to you. Form the skew symmetric matrix that would be given by the relation already shown to you. Okay. So E equal to the product of these two particular matrices that will match exactly with option number C. Just 1 second. Yes. What happened? Okay. Just 1 second, guys. Yeah, it would exactly match with option number C. So this is how you will solve in the examination. In all of the 10 questions which I have showed you, much calculation is not involved. Okay. Not much of the calculation is involved. Basic things are there, just you have to be a little bit careful. Okay, and you have to perform all the tasks. Okay, Much calculation is not there, a little calculation is there, okay, which you would be able to solve if and only if you are you are focused enough and you are practicing. Okay, this is the thing. Yeah, geometric interpretation. Okay, E is having rank 2. Okay, that epipolar line all passes through the epipole in the each image. Left epipole E satisfies capital E into small equal to 0. Right epipole E satisfies E dash E prime satisfies capital E transpose E dash equal to 0, and they are the images in the opposite camera center. Normalization, this derivation in the camera normalized coordinates to get the unnormalized fundamental matrix F would be already shown to you. K dash uh, transpose E means first of all you have to take the inverse, then you have to form the transpose, then E K inverse. Okay, that is the relationship for the camera normalized coordinates. Okay. So E is nothing but T dash skew symmetric matrix T multiplied by R, where T dash is the translation of the right camera center expressed in the left camera's coordinate frame, and T dash is the 3 by 3 skew symmetric matrix of T dash encoding the cross product. So R given to you, T dash given to you. Okay, V already given to you, T dash already given to you. Try to calculate both the things. Okay, V, any relation you can just try to remember. If a particular coordinate has been given to you at as x y z transpose, then how to calculate the q symmetric matrix. Okay, any relationship you can always try to remember. Okay, multiplying everything. Okay, row by row or element by element matrix multiplication already given here. Okay, you can perform the same check step by step. You will always reach at step number option number C. Okay, this one would be correct. Rest of the options wouldn't be. Okay, skew symmetric. If you just want to know that how this particular relationship has been coming, okay, the skew symmetric matrix Vx, okay, I am denoting it by Vx, okay. Simply a 3 by 3 matrix when multiplied by any vector b, it will reduce to the cross product V cross B. Okay, suppose V is this particular vector, B is this particular vector, then V cross B would be given by this particular relationship. Then if you will try to observe this particular bilinear structure, and if you try to assemble the matrix row by row, then you will get the exact relationship of Vx, which is shown here. Just 1 second. Yeah, which is shown here. Okay, so this relationship has come through this particular derivation. Okay, which I have shown here. It is not like that ki it has come from nowhere. It has come from this particular derivation, which I had been using in multiple questions. Okay. So T, if it is given to you, then substitute everything as equal to 1 and directly you would be able to calculate the skew symmetric matrix. Okay. Cross product is the bilinear in its two arguments. Okay. Skew symmetric matrix collects the coefficients needed so that V cross uh, V skew symmetric matrix. Okay. B equal to V cross B. It entries come directly by matching the component formula. Okay, this lets you replace every component in the epipolar formula with a simple matrix multiplication. Okay, for simplicity, I have reduced, and from where the particular relationship has come, I have already shown to you. Okay. Now you come towards the question number 10. Consider a stereo imaging setup with two cameras P, which is the left camera, P dash is the right camera. If the image coordinates of a 3D point are 10, 3 and 15, 3 in left and right cameras, compute its depth in 3D. Okay, try to do this, and you just have to calculate the magnitude of the depth. Okay, try to do this. Okay, answer one in depth. Okay, very good, very good. We'll just see. Just wait for some time. Let others also solve. Yes, if you will try to just see, okay, depth will be one only. Okay. In your stereo vision system, okay, or in your stereo vision, recovering a 3D points depth from two image projections is a special case of triangulation. Okay, each pinhole camera points towards the 3D point capital X, okay, which is x, y, z, one transpose in homogeneous coordinates into a 2D point, okay, which is a 3 by 4 projection matrix P, okay, for our two cameras P and P prime, okay. For the left camera, okay, P, it is 2x plus 0y plus 0z plus 0 into 1. So it will translate to 2x, 2y, 2z. For your right camera, it will translate to 2x plus 5, 2y plus 2z. Okay. So you just have to equate them with the corresponding homogeneous coordinates. SU, SV and S, or S dash, U dash, S dash, V dash and S dash. Okay. So you are given u comma v equal to 10 comma 3, u dash comma v dash equal to 15 comma 3. So if you try to put u as 10 you will get x equal to 5z. V as 3, you will get y equal to 1.5z. Okay. Then using your right camera's equation u dash, okay, u dash equal to 15 means 2x plus 5 over z equal to 15. Okay, substituting x equal to 5z, okay, you will get z as 1 and v dash as 3. So your back projections rays from the left image point, you get a ray which is defined by x comma y comma z, where fx fy is equal to 2. Okay. So for your right image, you get the second ray offset by the camera's baseline, and in your all the cases solving the all the parameter equation, you will get z as 1, as well as if you are not interested in this much long story, then you can directly use the formula k multiplied by t x dash minus x. Okay. So whichever approach suits you, you can always look for it. Okay. Or yes, only both of these approaches are there. So if you will notice the horizontal shift between u and u dash, which is the disparity, u dash minus u is equal to 5 in your standard stereo model D is inversely proportional to the depth. Okay, f is the focal length. Okay, and baseline in the is the focal length is the and b is the baseline. Okay, in case you will solve all of these, you will multiply focal length b baseline, okay, 5 by 2 divided by d is given to you as 5. When you will try to solve, you will get the distance z as 1. So triangulation uses two or more projections and the known camera geometry to solve for the 3D coordinates, and your depth z emerges from solving linear projection equations, essentially finding the two projection rays where the two back projection rays intersect. In your rectified stereo, this simplifies to z equal to f multiplied by capital B divided by small d. Meaning of every term and notation is there in the slide. Okay, and then you try to put all the values and solve for capital Z. These were the 10 different types of questions, okay, which I wanted to discuss based on the previous week's content. Okay, in front of you all, I have discussed these many number of questions. Okay, just 1 second. If you have any doubts in any of the questions, okay, feel free to ask me. Okay, now or at the later part of the lecture also you can ask me. Okay, now I'll try to show you some of the principal applications of stereogeometry, as well as some of the advanced computations, as well as the advanced concepts of your computer vision. What are the practical applications? Because a lot of you already have asked me, sir, you are not showing the practical applications, it is just theoretical. What we'll just get after calculating all these different number of parameters, this I'll just try to demonstrate using my own research, uh, as well as the other researchers also, research papers also. Just bear with me for a few minutes, I'll just try to show. Okay. Yes. Okay. Try to be a little more interactive, okay, when it comes to the application part. I know that lot of students are fairly bored, okay, when it comes to the mathematical expressions, okay, but now we will discuss some of the very interesting mathematical concepts. Okay, just a second. Yes, I hope that my entire screen is shared. I'll just share it. Okay. Yes, I think I'm sharing my screen. Okay, try to see here. Okay, this particular research paper. Okay, try to be a lot more interactive because this is something which is beyond the scope. Okay, somewhat beyond the scope, but the practical aspects of the computer vision starts from here only. Okay, this is from my own research. Okay, neuromorphic computing spiking edge neural network or the spiking neural network edge detection model for your CBIR. What is CBIR? I'll explain you in brief. CBIR is the latest advancement in computer vision in which you are able to perform the analysis on the image database that what is the exact content of the image. Okay, what is the exact content of the image means what are the different spatial features. Okay, various geometries it will try to compute. Okay, as well as not only through geometries, not only through edge detection, not only through face detection, it will try to generate what is the content of that particular image. Okay, whatever the applications, latest applications of the involvement of AI inside the image processing which you are seeing, these are nothing but the extensions of CBIR, which is nothing but the context based image retrieval. How AI is able to generate a particular image. Okay, means if you will try to just say it that generate a leaf, it will try to generate a leaf because it has learned from its past experiences what are the different spatial features, what are the different geometries. This all come under the broad domain of CBIR, which is nothing but the content based image retrieval. Means you are taking an image, you are performing the analysis, but not only you are calculating the spatial features, you are not performing the simple edge detections. They will come. I think in week number 6, week number 7, you will learn all the aspects of the simple Sobel, Kenny, as well as different types of image detection models. You will just try to see edge detection models. You will just try to see, but there you will analyze that they are only related to image manipulation. Okay, simple image manipulation, just like that. Okay, but our job is not limited towards that particular purpose only. Okay, our job is much beyond of that. Okay, so much beyond of that means I am showing you a particular photo, and if you are not able to classify immediately that what are the different spatial features, okay, then my image processing will be restricted. This particular concept from where it has emerged from your pattern recognition. Okay, pattern recognition. This particular concept emerged in 1993, where first of all Apple only taken the lead. Okay, it particularly jumped towards making a computer vision model which can recognize different numbers and translate it directly into your numerical format. Okay, so if you will show one written in front of the camera, it will just translate it or type in Microsoft Word as a numeral 1. Okay, so that was the initial aspect until whatever the advancements we have made because we have tried to always enhance our imaging, enhance our capabilities. Okay, so you also as a researcher or as an industrialist or as a startup or even as a BTech student, as a as a simple student only, just try to enhance your performance in that same format manner. Okay, in which we have tried to enhance the performance of the computer vision models. Okay, so here if you will try to see, this is from my own research in which I have used this particular CBIR model. If you want, I can provide the PDF also. Okay, you can read it down. Okay, I'll just provide it to you. Okay, so just one second, I'll share only. Okay, in the chat box so that in future also, if any student is interested. Yeah, this one is my profile. From here, you can directly download it. Otherwise, if you are unable to download, then please tell me. Okay, then I'll just download the PDF and then I'll share it as a Google Drive in Google Drive. Okay, but let me just explain this particular thought. Okay, this particular one is the introduction, not going to through deep inside it. So see, first of all, you try to see that this is the fundamental aspect. Okay, Even as a researcher, sometimes we also get confused that from where to start. Okay, so what I have learned from my research experience, that what is the starting point? Okay, if that question arises into your mind, always look towards the nature. Okay, always, always, my dear students, please look towards the nature. Okay, how nature is performing a particular task, that will give you the inspiration that how, sir, I can manipulate the whole story of stereo vision which I showed you. It has come from our own visual system only. Okay, and similar to that, I in this research paper I presented neuromorphic computing spiking neural network model. It seems a bit complicated, but it is not very complicated. You just try to see here, there are ganglion cells present in the retina of our eyes. Okay, they formulate the images. Okay, how they formulate the particular images, and how I am able to distinguish between two different colors that is shown in this particular figure. Okay, reference also has been provided here. If you want, you can read the reference also. Our ganglion cells which are present in the retina of the eye, they are very sensitive to the light intensity. Whenever I am seeing a particular image or a particular object, okay, right now I am seeing the computer screen, why I am able to perceive different colors of the entire screen, because of the fact that my ganglion cells are generating spikes or generating spiking signals. They are sensing the color. Okay, they are creating image of from the image of the from the image which is formed on the lens. They are sensing different types of colors in a particular RGB image, and on the basis of the particular colors of the RGB image, they are sending different spikes inside my brain. That is why I am able to distinguish between the gradients of the colors. So this one is the very fundamental of neuromorphic computing. In every domain, if neuro word is used, okay, neuro means nothing but the human mind. And this particular paper is based on the HVS only, human visual system. Okay. So if in research area, or in your even in your daily life, if you face any type of problem, you want to solve it practically for the benefit of the people, or for the benefit of the whole world, then go out, look into the nature, spend some time, and then you would be able to realize that nature already has solved this particular problem in one form of the another. Whether it is your genetic algorithm, whether it is your particle swarm optimization algorithm, all the optimization algorithms, whether it is your tracked vehicles, whether it is your Firefly algorithm, all the algorithms, Grasshopper algorithm, whatever algorithm you can see, they all have come from the inspiration from the nature only. I can keep on talking about this for few hours, but it would not serve the purpose. I'll just show you the principal application. Okay, here related works are written. Okay, then CBIR, different model, different precision, recall, F1 score, all the things I have written here. Okay, as well as here what particular model I have used, that is conductance based integrate and fire neuron model. The spiking neural network, which I explained to you in much simpler terms, that is mathematically defined. Okay, when the things are mathematically defined, then only the things are in such form and manner that they can be used by the good amount of people. Okay, so you try to see, then you try to see what particular model I have implemented. I have used n number of neurons. Each particular neuron is having particular spike, and at the end I have summed all for calculating the different synaptic connections have been shown here, and at the end I am classifying it belongs to which particular category. Okay, so this is the proposed edge detection model, as well as the neural network interference of that. Okay, this is all taught in, I think, till PhD level only. That is why I'm not explaining much, but principal application I'll just show you in just few slides. Okay, just scrolling down, because for explaining this I at least require 3-4 hours. How I came up with all those things. Okay, in 3 hours I'll just be able to explain you, but for making you do this, at least it will require me 2-3 days. Okay, after that I'll be in such a position. Here I've compared the results with 17 other people. Okay, 17 different models as well as different data sets, but principal application is shown in this particular slide only. Okay, my dear students, you can see in column number A, original grayscale image is there with three different data sets. Okay, for Kenny edge detection model, our this particular result is shown. For Sobel edge detection model, this particular model is shown. But for your proposed spiking neural network, you can see whatever are the illumination conditions, whatever are is the quality of the image, whatever things are there, it is always able to solve our problem of edge detection. Okay, that is why the model is very superior in comparison to 17 other people. Okay, I've compared all the results, okay, and provided my findings at the end. Okay, my dear students, this is the comparison, and at the end, I have provided the conclusion. This particular one is the principal application of spiking neural network, which is nothing but the aggregation of your spiking neural network applied to CBIR. Makbul, did you get what is a spiking neural network? Or you didn't get? I need to explain it once again.
Yeah, just check it. I will check it, and if any doubt, I will
Okay,
tell.
okay, okay. I'll explain it in brief. Okay, spiking neural network, already I told you. Based on the ganglion cell response of the retina. First of all, you have to understand what is front propagation, what is back propagation. Then you will be able to understand that what is this application, what is the spiking neural network. Spiking neural network, nothing but the principal application of the ganglion cell response of the retina. Okay, how in a particular two-dimensional image which is formed on the lens, our ganglion cells are able to distinguish between different colors. They are able to do so because a particular light intensity which is sensed on the lens is sent as a spike to our brain. That is nothing but a spiking network. Okay, spiking network means one spike, two spike, three spike. Then after, from all these spikes, the brain is able to process this particular information. So in your Laplace transformation, in your time theory, you must have read the continuous signals. Okay, in your in your signal processing, there is one term which is known as continuous signaling, continuous processing signals. Okay, or continuous signals. So when continuous signals reach to the brain, the intensities based on the color, based on the intensities of the spikes only, the judgment is made that this particular pixel is corresponding to which particular pixel, which particular color. And you would be surprised to know that in our particular Homo sapiens, in our species, human species, the male members are able to perceive 2 lakh colors, while the females are able to perceive 3 lakh colors. That is biological difference, okay, between male and female, okay. And you would be more surprised to know that this is regarding the HVS, human visual system. But you would be astonished to know that nowadays researchers are trying to research on crocodile size. Okay, because they are evolved since the time our Earth got evolved. Okay, so the eyes of the crocodile, they are the most ancient ones. So whatever the recent advancements you would be seeing, okay, they would be corresponding towards this particular uh, eyes only. Okay, eyes of that particular species only. Okay, so please try to some type of research. Okay, if you are interested, try to see what are spiking neural networks, how you can implement this particular spiking neural network in Python. Okay, and try to make a GitHub repo after the class is over. Try to spend some time make a GitHub repo, fetch some images, try to find out some principal applications. Okay, it would take around 1 2 hours of yours, but you will learn a lot. That is was the principal purpose of me sharing this particular information. You won't be able to do this much of advanced research in such small time, but at least you would be able to perceive what are different things, what are different applications, and this would be very much helpful for your CV. Okay, if it is a public GitHub repo, you can always share in your CV also. Okay.
Also,
Yes.
I check out one thing that mosquito does not see anything, any color in there.
Yes, 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 yes. Mosquito does not
Yeah,
perceive any colors. Still, it is able to bite us. How do you know?
sense.
Yes, through the sense of smell, taste.
Yeah.
Okay,
Also, I check out some animal details. I cannot remember now.
okay, okay, okay.
Cat or cat are maybe color
Yes,
detection
yes,
will be different way.
yes, yes. Their color detection is in a different way. Why we are trying to replicate our own system? Because the principal applications of computer vision is limited to us only. If we are trying to perform some kind of we are trying to perform some modeling, okay, of other species like dogs or cats, then we won't be able to make such AR VR arrangements for dogs and cats. We the principal buyers are not dogs, cats, mosquitoes. Okay, that is why every species is having a different visual system. That is just for the basis of studying. But why I'm just explaining that we are using HVS or advanced form of vision models as compared to HVS because of our potential application in this particular field. Okay, that is the reason. Yes.
Okay, thank you.
Okay. Yes. Now we'll try to see some more of the applications of stereogeometry. Okay, stereogeometry. I'll just research in front of you only. Okay, stereo. Why I'm performing this research in front of you so that you would be able to appreciate that how in general research is also done. Okay, this is the thing how you should do. Some different types of websites are there. Okay, researchgate is particularly good. Academia you can use, lot of things are there, but principally if you want to do some academic research, always go for Science Direct, go for Springer, Taylor Francis, Nature. These are very good publications. If your university is not subscribing to those particular publications, don't be afraid. Don't say to me, sir, I am not having access. Go for open access papers. You will always get some open access papers. Okay. This is how you always have to perceive. So here in this particular research papers nowadays, these concepts are now being applied to UAVs. UAVs are also using the concept of your stereo vision. Okay, stereo vision for low flying UAVs has got much of the much of the application. Okay, here you can see different types of sensors. Not much explaining about that because this comes under the broad domain of mechatronics. Okay, then you try to see here mirror assisted multi-view digital image correlation. What are the what particularly in this research paper they have used multiple views, mirror assisted multi-view. Means first of all they'll use the concept of stereogeometry. Stereogeometry is nothing but capturing two particular images and then combining to form a particular 3D view or calculating depth. Okay, this is the concept of stereo vision, but not restricting towards that. We can always go for multiple view, mirror view also. Okay, so when you will be increasing the number of faces, the chances are that you would be able to obtain the 3D depth reconstruction also in 360 degree. or in the entire 360-degree AR VR applications. Okay, so this is regarding your multi-view camera vision system. They have used the camera, then you have used the synchronizer. Synchronizer, what is the principal application? If you know the basics of signal processing, then synchronizer is a particular device that can manipulate different signals in different frequencies and time domain, and it can provide you the signal in a single time domain. Means if you want that, if you are receiving three particular signals and they are varying in x, y, z dimensions, okay, and you want to match those three particular signals and you want to see them on a particular axis, okay, all of those three in on a particular axis synchronized, then you have to use a particular instrument which is known as the synchronizer. That is what being used here. Okay, so they have tilted the entire geometry in uh, one plane, and then they have tried to create the virtual object. Means when it comes to different mirror images, okay, you are using different mirror images, like here where my cursor is going, one particular mirror is there, another mirror is there, then sample is there. They have used three different cameras, and then they have adjusted different types of angles. Okay, so what principally they are doing, they are trying to create the entire virtual object through these particular setup of cameras. Okay, so they are using various geometrical parameters, but this is the very basic of 3D reconstruction. Okay, this is how you would be able to perform your analysis. Okay, this particular concept is very, very useful when we are performing the micro material analysis as well as the nanomaterial analysis. Okay, at our IIT Kharagpur, we are having a particular department which is nanoscience department. Okay, for those people, it is very, very important for capturing different views and creating an entire 3D reconstruction of the particular object which they are perceiving. Okay, so in their department, this particular facility is there. If you ever get a chance to come here, then you can visit. Okay, this is one principal application using different mirrors to perform the 3D reconstruction, and then you analyze different performance, you perform different types of image transforms. Okay, then you perform the analysis. Okay, this is image analysis of different nanomaterials. Okay, then you try to perform what is the captured image and what is the profile, what is the principal strain. Okay, why we are interested in calculating principal strain, why we are calculating in interested in calculating this particular stress strain analysis, because for nanomaterials as well as for the various high end wearable devices, for your implants, this particular information is very, very important, that how stress is varying with respect to different movements, okay, which we'll try to perform. So for those micro materials, the stress strain analysis is done in 360-degree view. And for performing that, we need image data as well as not only the RGB image data, but also thermal image data. Okay. Change the camera, change the different profiling, and try to capture everything in three dimensions. So this particular one is the application of stereo vision along with your mirroring. Okay. Then they are concluding their work and they are doing all those things. In good research papers, it is always a characteristic to give the source codes. Okay. Yes. Advanced materialing, sensing, drilling, this is not related. Then 1D, yeah, 1D approach based stereo matching. What is stereo matching? Very, very important term is there. Stereo matching is nothing but when you are lost. Okay. When you are lost in space, means in three dimensions, you are lost. Okay, and you don't know that from which particular coordinate, what is the distance, then what is the distance of another coordinate. Then you take a random point, then you try to calibrate your camera first. That is the basic of stereo matching. Stereo matching is particularly useful for your one-dimensional, two-dimensional, three-dimensional optimization algorithms. Okay. So in those particular aspects, that is very, very important. Okay, basic only I am telling you, I am not diving deep into the mathematical aspects. You try to revisit yourself. Okay, if you feel interested, you feel any doubt is there, then they are proposing a new 1D approach. Okay, means they are reducing the dimensionality. Then they are performing the fuzzy logic. Okay, fuzzy logic is nothing but a rule-based mechanism. Okay, means while grading also some criteria is there, like 91 to 100 is EX, like 80 81 to 90, that is grade A, or similar range is there. So similar to that is fuzzy logic, which will try to classify the decision mechanism process based on the rule base, which is decided already pre-decided during the training of the network. Okay. So this is regarding your stereo matching, and this is the disparity map which we have formed, the ROC curve. These all are principal applications you will learn in this course only. Okay. Some of the things like ROC curve, what is training data, what is testing data, what is precision, what is recall, what is F1 score. These all the aspects we will learn in this particular in this particular course only. Okay, that would be there. Bear with me. Okay, what are the different things? And here you can see it is stereo vision application is well logging drilling and completion operations. Okay, so applications are multiple, just the thing is that you have to master the concepts. Okay, not just mastering the principal concepts, mathematical concepts, but also nowadays sincere advice to you is that application also you should know. Application, how you will know? When you will try to code this particular thing in Python, then make a GitHub repo, try to do some principal applications. Like today I told you about spiking neural network, do your own research. Lot of AI tools are there. Try to make some of the GitHub repos, try to share on public platforms. Also, you can tag me also. Okay. So these are the these are the efforts which when you will make, then your future uh, aspects or future career aspects will be very bright. Okay, this is the thing. Then this stereo vision application, left camera, right camera, the planes, the epipoles, everything has been mentioned here. Then they are calculating what is the depth, this particular formula, the answer already you have given as one. Okay, so same thing they are using for oil logging, well drilling. This particular camera is there, then time of flight they are using. All the things are there. Okay, you can always go for it. So application, what they are trying to do, which I can just infer, that they are mapping the oil level. Why it is very useful? Because mapping of the oil level is very essential. Because when a oil well is made, it is made for more than 1 year, 2 year, 3 year, 5 years. Okay, so till the end of the 5 years, continuous oil drilling would be there. Okay, 5 years, 10 years. Okay, so if we don't know what is the oil level and how the oil level will decrease or increase with due course amount of time, then our pricing or the money would be lost. Okay, if we start drilling in a particular wrong direction, then the oil rig, it would be just a waste. Okay, so for that particular purpose or that particular principal application, we try to measure what is the oil level. Okay, and how we try to simulate. We perform the simulation for even years before setting the oil rig at a particular place. And for that, different types of sensors are used, but one of the principal application is stereo vision camera only. Okay. So don't restrict yourself to the mathematical aspects only. Try to code these also. Try to make a GitHub repo also, and try to post it on any of the educational platforms. Okay, whichever you feel, and then it would be very much useful for your future career aspects. In the similar fashion, I'll just try to solve 10 questions in our my upcoming session also. Okay, and then at the end we will discuss some of the practical aspects along with my own research. If I carried out in this particular field, I'll definitely show. But if I am not able to show, okay, I'll use some of the other researchers' work also. Okay, with due citation, you can always use. You can always write research papers also. You can present it to various firms, organizations. Okay, and if you are very much interested, my sincere advice to you is that always in any of your work, if you are posting on any of the website, okay, then please, my sincere advice to you is that, my dear students, please have a signature on it. Okay, means don't copy some of the things which are already there and you are posting them. That won't be very catchy. Okay, that post won't be very catchy. Okay, so sincere advice to you is that have a signature. At least have a signature. Have a distinct signature. Okay, have a distinct signature. Meaning is this. Meaning is nothing wrong. Okay, meaning is just like this, that try to build some of your originality in the work. Okay, like you are writing a letter, then it should feel like that you only have written that letter. Nobody in the entire world has just written a letter like you. Okay, because nowadays if you will just post some of the application which has been already present in the real world scenarios, then it won't be catching much of the attention. The only thing which can make you differentiate in your professional career, in your professional career, is originality only. Okay, so sincere advice to you all is this. And Makbul, I appreciate 1 hour question, 1 hour application, use case discussion, everything. Okay, very useful suggestion. Okay, in if in 1 hour I am able to solve 10 questions, then definitely it would be so. And in 1 hour I'll discuss all of the applications. I'll try to perform some code analysis also along with you. I'll try to explain in Python also. Okay, I'm very well versed with it. So I am very thankful for your suggestion. I'll try to follow. Okay, in the next class, from next class onwards. Okay, I'll try to make it more application driven also. Okay. Mm, if after the mathematical part is over and I am left with some time, okay, I'll definitely try to extend it towards the applications. Okay, so thank you, my dear students, for joining the session. Okay, thank you all. Okay, the session is over from my side. If you have any doubts, feel free to ask me. Okay, my principal job is to explain you the mathematical questions only, 10 questions only. Okay, so if at any point of time you are having any doubt, feel free to ask. In an application side, you are having any doubt, feel free to ask. In your research side, you are having any doubt, feel free to ask. Okay. Thank you all for joining the session. Do join the session in the next week. Okay. Next week, same time, same link. Okay. Thank you all. That's
Thank
from
you,
my
sir.
side.
Thank you. Thank you so much.
Okay. Thank you so much. Okay, students, thank you so much for joining the session. Do join the session next week, same time, same link. Okay, thank you all. I'm ending the session here. Okay, thank you.